X mark.
What is the limit within which we want you to score? We definitely want all of you to score above 60 because 60 is the pass mark. So what is 60? 60 is the lower specification limit. Is there an upper spec? The more is better. To score any value, process is not sensitive on the right side, but process is sensitive on the left side. There can be a rejection possible. Below 60 fail mark, isn't it? So you only have lower spec. But theoretically, we have an upper spec, or practically we have an upper spec because there is a maximum mark. You can't go beyond that. So upper spec is 100, lower spec is 60. If you are okay with the specification limit, now you can calculate your capability. Or do you want to change? Please change your specification and then go for the calculation. Now all of you tell me, is the idea of 60 and 100 is good? Or do you want to be much more safer? Because 60 to 100 is very, very wider range. The wider the range, poorer is the control. Isn't it? Or can I make it 80 to 100? That will demand, a process with with the higher capability, and definitely that will demand higher control. 100% attendance is compulsory. Then only, we can shift that mark to 80 marks, isn't it?
Yeah.
Those who miss even a single class, they are not allowed for the exam. So we need to have more control. So you need to understand, right? And okay, let me just for discussion purpose, let me say 80 to 100 only. Let's think about a situation where higher level of control is needed. Lower spec is 80, upper spec is 100. So what is that I am targeting now? I am targeting 90. Because my lower spec is 80, upper spec is 100, that means I am targeting 90. How do I know 90 is the target? That's the center point, pick point. Yeah. Average, you should also think in the same manner. You might be controlling the dimensions. Length of a product need to be 100 plus or minus 0.5, or the surface finish should be some microns, 50 plus or minus 3 microns, whatever. Now upper spec, lower spec, and the midpoint is the target, right? So here in our case 90 is the target and 100 is the upper spec and 80 is the lowest spec. Now I need to ensure each one of you score inside this. If each one of you have to score inside this, always your average mark should be around 90. The class average, every batch we run, when we calculate the class average, like defined phase, all of you are practicing, isn't it, your mock exam? All of you collect all your marks, put it in a single Excel, and then calculate the average mark. And that will give an indication about the overall performance of the batch, not the individual person's performance. Please note, you are concerned about your mark, but we are concerned about the entire batch. Am I correct? Yeah. So the average, we need to always look at the average, and we should expect the average closer to 90. If this is not happening, that's an indication of poor control. Let's say the class average is only 65. What does it mean? We targeted 90, but class is performing, around 65. That means there is a poor control. Your people are not at all, listening to you. You are telling, you are giving so much instructions, nothing is followed. You do have instructions in your company, isn't it? You have SOP. And if nobody is following, then what will happen? You will see the average, pulled downwards or pushed upwards. If your average is pushed downwards or upwards or left side or right side, will it not be a problem for you?
Yeah.
If the average itself is pushed towards one side, that means there is a big problem happening in your process. Because I'm not talking about individual value. If one person is not scoring and I can just sit with him, but if the entire average is shifted to the left side, then I have to sit with all of you. Yeah. Everybody is having a problem, like Pongal festival, Sankranti. Everybody celebrated and everyone has forgotten the concepts. Now it is, definitely, a session has to be organized to recall. You understand? So average is one thing. Another thing is the spread in the data. You now understood the average. Now, what is the mark scored by individual student? How far the individual scores are from the average? If a student has scored 95, but my average is 65, he is a brilliant student.
Yeah.
He is a brilliant student. He is a brilliant student. Though he is brilliant, which is a positive situation for me, I could understand the deviation is too high. Isn't it? Deviation is too high. Deviation from the mean is too high. What this situation is telling? This situation is telling when entire class is performing in a particular manner, this individual alone performed differently, maybe positively or negatively. But in this case, what example I told, it's positive. Positive means you discuss with him, try to understand his tactics, try to pass on the tactics to other students. You understand? If I all the best practice, good practice that particular individual had, if I share that information with all the other students, I can see my average moving upwards, which I wanted, isn't it? So see, deviations can be good, can be bad. But in a manufacturing scenario, both deviations will be bad for you, isn't it? Because going outside the upper spec also problem, below lower spec also problem. But in my case, if a student is scoring a higher mark, which is far, far away from the average, this is what is known as deviation. So deviation means what? Deviation from the central value. Deviation means deviation from the average. Do you think every student will have a deviation?
Yeah.
Every student will have a deviation, isn't it? Some people will have positive deviation. Some students will have negative deviation.
Yeah.
Positive deviation means above average students. Negative deviation means below average students. Every student has a deviation. This deviation is what we call it as variation. We want to minimize this variation to say that we have good control over the process. Even though one student got 95 and the other student, the class average is 65, but there are students who scored in single digit also. This is clearly indicating that there is a poor control over the students or poor control over the process. So now, what is the total variation, total deviation? Can somebody tell me, will I be able to calculate total deviation? Let's say the class average is 65 and we have Gaurav. Gaurav scored 95 marks. Now, what is the deviation for Gaurav?
5, sir.
No, 65 is the class average. And Gaurav scored 95, I said. Now, what is the deviation?
30.
Class average is 65.
30.
His mark is 95.
30.
30 plus 30, positive deviation. And now we have Kiranmai also. Kiranmai scored only 30 marks. I don't know why. But class average is how much? 65. But he scored only 35. Now, what is
Minus
his
30.
deviation? What is his deviation?
Minus 30.
Minus 35.
Minus 30. I am worried about both deviation. Why is he studying very good? And why is he studying so bad? One side there is so good performance, other side there is so bad performance. What I want is, I want everybody to perform at the same level. All right. So now the positive deviation of 30 and negative deviation of 30, I want to take both into account. When I sum them up, plus 30 and minus 30, what is the total deviation?
60.
Very good. You are so nice with mathematics. You adjusted and then you calculated, right? There is plus 30 and there is minus 30. When you actually sum it algebraically, plus 30 and minus 30 will cancel each other. And total deviation will appear as 0. So what we do is, we don't go for algebraic sum. We'll go for statistics now. What I do is, his deviation is 30. Your deviation is minus 30. I will square his deviation also. I will square your deviation also. Why am I squaring here? because one of the deviation is negative. Yes or no? So they will cancel each other. So I don't want them to cancel each other when I sum them up. So I square them and then add them. 30 is squared minus 30 also squared. When I square 30, how much it is?
900, 900.
900. Similarly, minus 30 also when squared, that is also 900.
900.
So these both 900, I will sum them. I'll add them now. Now it is 1800. This 1800 is an indication of the deviation in my process. More the deviation, lesser the control. Now this 1800, I will divide by a factor known as degree of freedom. I will divide by a factor known as degree of freedom. Degree of freedom depends on number of data. How many examples I have taken here? Gaurav?
2
Kiran.
examples.
Only 2 data point. So 2 minus 1 is how much? 1. So this is known as degree of freedom, n minus 1. Right? So 900 divided by 1 is 900. Clear all of you? 900 divided by 1 is 900 only. This 900 is...
1800, sir.
Oh, sorry, 1800. I'm sorry, 1800. This 1800 is nothing but is known as variance. This 1800 is known as variance. Now I want to know the standard deviation. I just square it. I just take a square root. For 1800, I take a square root. Can somebody find out how much is square root of 1800? Calculators available? Yeah, square root of 1800 is how much?
42.46.
42.42. This is known as standard deviation. Square root of variance is standard deviation. When I square this 42, I'll get back my variance. So the 42 is an indication of the variation in my process. And we normally use standard deviation to understand the variation. There is one other way, simple way to understand the variation, which is nothing but calculating range. Can somebody tell me what is range? What is range?
Max minus minimum.
That's all. Maximum mark is Gaurav and minimum mark is some student. So Gaurav scored 95 and minimum mark is 5. Now what is the range? 95 minus 5? 90.
90.
This is also an indication of the spread of the process or variation in my process. Isn't it? Do you understand, all of you? This is also a way of understanding the variation. But when I use range, I am using only the maximum and the minimum. I am not worried about the other students. That's why range is not always recommended. When there are only 3 students, 4 students in the class, you calculate range. But when there are too many students, then you must calculate standard deviation in the way I explained, which can be a better estimate of variation. Clear, all of you? So what I was trying to say is, I want you to be, concerned not only about the average, but also the deviation. Also the variation. Average, what is the requirement? Average should be on the target. Average should be on the target. If every other data point should be closer to the average. If every other data point is closer to the average, your standard deviation will be minimal. It won't be like 42 or 45. Do you understand, all of you? If every student has scored, closer to the average, then when you calculate standard deviation, it will be very, very minimal, right? So if the standard deviation is minimal or range is minimal or variance is minimal, that's a strong evidence that you have effective control over the process. How many of you understand this? You have effective control over the process. When you have an effective control, additionally, if you have average on the target, you are simply making your process capable. When you have effective control over the process, what is the indication statistically? Range will be minimal. Standard deviation will be minimal. Variance will be minimal. Out of the three, use standard deviation. Can give a more clear picture. Out of range, variance, and standard deviation, which can give more clear picture?
Standard deviation.
Standard deviation. So check standard deviation. If standard deviation is too small, be happy about it. It means you have effective control. Everyone is following your instruction. After that, check where is your average. If your average is now on the target, your process is not only under control, but also capable. All of you are with me on this? Let me tell a scenario. Class average is 90. Standard deviation is just 2 marks. Tell me, is this process under control? Compared to our original discussion. Our original requirement is lower spec 80, upper spec 100. Now, where is my class average?
90.
90. That means, can you see my class average right on the target?
Yes, sir.
That means whatever I wanted, that is happening. Whatever I am praying to the God is giving me. Exactly, isn't it? Class average on the target. And standard deviation is 2 marks. Standard deviation just 2 means almost every student has scored around 90 only. Either they are 90 plus or minus, very few marks. And one more thing, please note all of you, when the standard deviation is 2, the maximum, you all know maximum, right? In any data, you can find out the maximum. Yes or no?
Yes, sir.
The maximum will be, is expected to be 3 standard deviation away from the average. In any set of data, the maximum is expected to be 3 standard deviation away from the average. In our example, what is the class average?
90.
90. And standard deviation is 2.
2.
Now you will be happy to see one student having scored 96 marks. 96 is the maximum. How is this 96 happen? 90 plus 3 times standard deviation. Your standard deviation is how much I said? 2.
2.
So 90 plus 3 into 2, the maximum mark is 96. All of you understand?
Yes, sir.
And the minimum will be 84. Now anybody scoring below 84, anybody scoring above 96 are considered to be outlier.
Out of spec.
Not out of spec, outlier.
Outlier. Okay, sir.
Outlier, out of control. I am going to question them. Anybody scoring above 96, I'll go sit with them and ask them, hey, how did you score above 96? This is quite abnormal for me, isn't it? Because it's an outlier. All of you agree? Similarly,
Yes,
below
sir.
84 also, I'm going to question. Below 84 also. See, if you actually think about a school scenario, 84, 83, 82, and all good mark only. But still, I am questioning. You know why? Because my process is designed to run between 84 and 96. So I have the guts to ask a question. Why did you score below 84? Do you understand? But if I don't have good control, I will not be able to question like this. I will simply say, okay, it's pass mark. Okay, chalo. All of you are with me on this? Now the customer has given me a specification of 80 and 100, but my process is comfortably operating between 84 and 96. Now my process is considered capable. Clear, all of you?
Yes.
So for you to say your process is capable, you should also look at your average. You should also look at your standard deviation. What is the requirement? You understood now based on the discussion. Average should be? Come on, yeah. Average should be on the target.
Target. Midpoint.
Average should be on the target or midpoint between upper spec and lower spec. And standard deviation should be?
Minimal.
Minimal. Very good. If you just ensure this, you can go for vacation 15 days. That's all. Nothing will happen to your process. No customer complaint, no rejections, no phone calls in the midnight. Everything you can avoid. All that you need to ensure is make sure your average is on the target make sure your standard deviation is minimal, and you should set a standard for standard deviation. Do you understand my statement? You should set a standard for standard deviation. You should be able to tell, like in the test mark example, what is the standard deviation I mentioned? 2 marks I said, isn't it? Same manner, you should be able to dictate your team. Standard deviation should never be more than 0.5. If standard deviation goes more than 0.5, then an attention is needed, isn't it? You have to investigate. You have to ask several questions. That's how you establish control. Clear, all of you? And very scientific way of gaining control over the process. And you're not simply going with opinion. If you go with opinion, sometimes your decisions will go wrong. But if you go with average and standard deviation, things just cannot escape from your eyes. Hope all of you understand whatever I spoke so far. You are able to follow, am I right?
Yes, sir.
So certain things we have seen, so I'm not going to talk about all of this. All this I have discussed with you on previous day. So straight away, I'm going to the CP and CPK. Now, very important thing as far as the CP and CPK is concerned is upper spec, lower spec, process average, process standard deviation. Process average, process standard. Just these 4 things, if you have, you can calculate CP and CPK. Yield, DPMO, all were taught to you. Yeah. Very good here. So now comes the formula for your CP and CPK. CP is known as potential process capability ratio. The name itself indicates something. Can you see the word potential here? Potential means there is a possibility. Potential means there is a possibility. CP doesn't confirm real capability, right? But CPK, it is known as index, process capability index, which means it has a measure of real capability of your process. So out of the 2, which is better? CPK is better. Why? Because it carries the real capability of the process, information about the real capability of the process. Hereafter, when you want to conclude about the capability, please look at CP and CPK. Sorry, look at CPK. Right? If you simply look at CP and make a decision, you may go wrong. But if you look at CPK and take a decision, you cannot go wrong. Why CPK is advantageous? Look at the formula. In CP, look at the terminology involved. What is USL?
Upper specification limit.
Yes. LSL means?
Lower
Lower
specification limit.
specification.
Sigma means?
Standard
Standard
deviation.
deviation.
Process standard deviation. Standard deviation calculated from the process data. So only this much information is used to calculate CP. But for calculation of CPK, here is your CPK. Look at the terms involved. Upper spec is involved. Lower spec is involved. Standard deviation involved. What is the other one involved?
Average.
X bar. Average is also involved. So CPK can give a better estimate of your capability. Better than CP. So CPK gives a realistic measure of capability, but CP can only give potential measure of capability. Clear, all of you? One has advantage, over the other, right? And out of the 2, CPK is better, but CP definitely talks about the control. CP talks about control, but CPK not only talks about control, but also capability. See, why am I very much concerned about the average? When you want to shoot the target, you want to know whether your bullets are closer to the target, isn't it? right? Whether your bullets are closer to the target or not. And particularly majority of the bullets, whether majority of the bullets are closer to the target or not. For that, you need to look at the average. If average is closer to the target or on the target, it confirms that majority of your bullets are closer to the target. Okay. And now you see a process here, all of you. There is a process. What is the upper spec here? 50.
50,
Lower spec is 30.
30,
So what is the customer targeting? Customer target is how much here?
40,
40. And now your process average, X bar. X bar is how much? X bar is also 40.
40,
Customer target is mu. Process average is X bar. All of you, do you understand the difference between customer target and process average? All of you, do you understand the difference between customer target and process average?
Yes, sir.
How do you
Yes.
understand customer target?
One target specified by customer.
Customers.
Specified by customer. Actually, it is the midpoint between upper spec and lower spec.
Yes, sir.
And you want to make sure your average appears on the target. And so in this case, X bar is 40, customer target also 40. It's a good scenario or bad scenario?
Good scenario.
scenario.
Good scenario.
Good
And
scenario.
now your process control limits. Control limits are nothing but the points, 3 standard deviations away from the center. Control limits are nothing but the points, 3 standard deviation away from the center. In this case, standard deviation is assumed to be how much? 2.
2.
2.
2.
So your upper control limit will be 40 plus 3 times standard deviation, 46. Lower control limit, 40 minus 6, which is 34. Now, are you able to see your control limits inside the specification limits?
Yes.
And now
Yes,
your
sir.
process is capable. The whole game of business in any segment is understanding the position of the control limit with respect to the specification limit. Whenever you see the control limit inside the specification limit, you can safely conclude your process is capable. Clear, all of you?
Yes, sir.
Very good. And now, formula wise, concept wise, we understood formula wise. You substitute USL, LSL. What is the difference between USL and LSL? 50 and 30.
20.
Can you see 20 here?
20,
20.
Yes, yes.
20. Similarly, difference between upper control limit and lower control limit, UCL minus
8.
LCL. 46
8.
minus
8.
34 is?
8, sir.
It's not 8.
That was
It's not
12.
8.
12. 12.
12.
12.
12.
And please note one more thing. So that 12, when I put it here, I am getting my CP equal to 1.67. Now, CP 1.67 confirms a strong statistical control over my process. Number one. CP 1.67 means strong statistical control. But visually, I can see my control limit inside the specification limit. Can you see visually? All of you, can you see from the diagram? Possible, right?
Yes.
I see my control limit inside the spec. So my process is not only under control, but also capable. But why do I bring the word capable here? Because I can visually see, isn't it? I'm not just looking at CP. Point number one. Another thing, upper control limit minus lower control limit. You all told me it is 12. Am I right?
Yeah.
Difference between upper control limit minus lower control limit is 12.
Yeah.
This 12 is nothing but 6 into 2.
Yes.
Am I right? 6 into 2. But what is 2? Sigma. So upper control limit minus lower control limit will be equal to 6 sigma. Am I right? The distance between upper control limit and lower control limit is 6 sigma. Am I right? All of you agree with me?
Yes.
Yes, yes.
I'm just writing here. Nothing wrong in writing this 6 sigma. And now this is how much?
3
Six.
sigma.
3 sigma. This is how much?
3 sigma.
So keep this information with you, right? This is some statistical relationship. This is statistical relationship, right? And see, okay. That's one thing. And also one more thing I want all of you to remember. If I consider all my products, if I consider all my products falling inside the control limit, remember this number also, 99.73. Where from I'm writing this number? I'm writing this number, from the normal distribution. From the normal distribution. According to normal distribution, or I can even say according to law of nature. According to law of nature. Law of nature is very powerful. Yes or no?
Yes.
Right. That is not, people in modern word, they call it as science. How nature behaves, that is called science, right? So, according to normal distribution, at least 99.73% of your products will appear inside control limit. What is the statement? At least 99.73% of your products, or in general outputs, will appear inside control limit. Can one of you be able to repeat this statement? Can anybody repeat this statement? Or you can put it in the chat box. According to normal distribution, or according to the property of normal distribution, 99.73% of your products, your outputs, or your population. You can use all these words if you know the meaning of it, right? You can call it output, you can call it products, or you can even use students. 99.73% of my students are expected to score between 34 and 46 if my class average is 40 and class standard deviation is 2. Yes or no?
Yes.
All right. So this is how you should speak. And now, according to this particular, slide, my process is capable, and the process is under effective control, statistical control. All of you understand why did I say there is an effective control? Do you know why I say?
This is chair, and I have only one doubt.
Yeah, please.
99.73 I can able to understand within control limit, but the 100% will be within the spec. Am I right, sir?
Correct. We can only comment up to control limit.
Okay.
And but if you want to go understand what will happen up to specification limit, you should know the value, and then you need to find out how many standard deviation is still there between your control limit and specification limit. See here, your control limit ends, right?
Yes, correct.
And your specification limit is here. Now this distance have to be understood. If you could understand the distance, then again you can go to normal distribution table and find out that extra percentage also.
Okay.
But very, very sure up to control limit 99.73. I'll show you in Minitab. Don't worry. That can be calculated in Minitab. All right. So now I show you another scenario. Now, can you see the scenario now? What happened to your process? Earlier it was like this, but now it is like this. Can somebody tell me what happened? What happened to this process? Process is shifted to the right side. Am I right? Earlier, you were holding the gun and the gun is pointing the target. And now in this scenario, if you release the bullet, yes, your results are extremely good. Am I correct? But now what happened? Suddenly, your gun has shifted to the right. Can you see your gun shifting to the right now? Come on, yes, speak out. Is your gun shifted to the right or not?
Yes, correct.
Yes. In this scenario, when I release the bullet, what will happen? Will it hit my target?
Offset.
That is what you are observing. That's what you are observing now in the slide. Your process, see here, your gun is tilted now. If you don't know how to hold the gun, better don't release the bullet. Am I right? If you don't know how to hold the gun, better don't release the bullet. What should you do before releasing the bullet? Bring back the gun to the right position, isn't it?
Yeah.
How many of you are doing this in your workplace? Whenever you see your average, shifting away from the target, how many of you are putting efforts to bring back the average? Very important, isn't it? The chance of your bullets hitting the target will drastically reduce when your process is off targeted. Am I correct? See, there is a quality guru who is known as Takuchi. Takuchi says you must try to produce parts right on the target. Don't try to produce parts inside the spec. How many of you are here trying to produce parts on the target, and how many of you are trying to produce parts within the spec? All of us want to produce parts within the spec, isn't it?
Yes.
But actually, we must try to produce parts around the target. That's the best idea. Particularly if you are concerned about warranty, if you are giving your product 6 months warranty, 1 year warranty, 2-year warranty, 3-year warranty, don't consume the tolerance. If you consume all the tolerance, do you think your product will survive for another 2 years? If you don't consume the tolerance, stay exactly around the target. Keep lot of excess tolerance. Even if your product is used for another 6 months, another 1 year, 2 year, even after 2 years, you will see your product inside the spec. Do you understand my language? So the best in class means ability to produce around the target, not within the spec. All of you agree with me? Okay. So now the previous case, the process is under good control and also capable. But now the process is off targeted. Process is off targeted. In this condition, if you calculate CP, what is the result coming? Can somebody tell me? Result is same result. Here also 1.67, here also 1.67. But we know the previous scenario process is capable, now it is not capable. Can you see your control limit going outside the spec here, all of you?
Yes.
So don't conclude about the capability just by looking at CP. Earlier, visually also it is confirmed. But here, the visual depiction is not confirming the capability. So that is why when you see CP in an acceptable value, what you can conclude is you can definitely conclude the process is under statistical control. The process is under statistical control. When your CP is okay, which means if you plot a control chart will also be okay. All right? Fine. So process is under statistical control, but not capable. There are rejections happening on the right side. So my advice to all of you, my piece of advice to all of you is don't look at CP to understand the capability. Then what for CP is given? To understand the control. Control is different from capability. Am I right?
Right.
Let's say a student scoring above 90 marks in all the 10 exams. He has a good control over his examination process. Am I right? He always scores above 90. 10 exams, all 10 exam marks are above 90. Can you see a good control here? Yes. There is another student who always scores single digit marks. 10 exam, all 10 exams, their mark is single digit. He also has good control, isn't it? Good control means consistency. One student is consistently scoring high mark, another student is consistently scoring low marks. So consistency is there. CP can talk about consistency. Right? So CP should be more than one is general requirement. But industrial standard, AIAG, Automotive Industry Action Group standard is 1.67. Right? 1.67 for critical process, critical characteristics, And for non-critical process, non-critical characteristics, 1.33. So CP cannot indicate our capability. It can only indicate our statistical control or consistency. That is why CpK is introduced. CpK, in addition to checking the spread of the process, will also check where is the center. And where do you want the center to be? You want the center to be on the target, am I right? You want the center to be on the target. Now see, can you see the center on the target now? Yes. When your process is centered on the target, the distance on the right side and the distance on the left side. I mean, the center, the distance between center and the upper spec, center and the lower spec. Can you see both of them at equal distance? Am I right? Come on, please confirm.
Yes.
The distance between process center and the nearest spec. The blue bar and green bar. Can you see both of them equal length?
Yes.
Come on, yeah,
Yes.
confirm. Yes or no?
Yes.
Yeah.
Now 3.
If my process is shifted, definitely this will, the balance will get, disturbed. If my process is shifted to the right side, you know what will happen? The blue bar will reduce. So this is the clue to understand whether our process is getting shifted to the right or not. So now in this condition, when you use the CpK formula is USL minus X bar divided by 3 sigma. Why 3 sigma comes here? Earlier, we considered a whole process. Now we divided the process into 2 parts. The right side part is only 3 sigma. Can you see here? Similarly, left side is 3 sigma. Always spread of the process is 6 sigma. 3 sigma on the right side, 3 sigma on the left side. Now, the ratio on the right side, USL minus X bar divided by 3 sigma. You can see here. This is known as Cp upper. Similarly, yes, ratio on the left side, which is X bar minus LSL by 3 sigma. Both of them, if they are giving the same value, you can understand your process is shifted. Your process is not shifted to the right, not shifted to the left. That is why Cp upper and Cp lower are same. The moment you see a different value for Cp upper and Cp lower, it is an indication that your process is shifted, which is not good, right? So out of the two value, whichever is lower, that should be assumed as CpK. In this case, since both are equal, your CpK is 1.66. Whenever you see CpK 1.66, you can simply conclude your process is capable. Because industry requirement AAG rule is 1.67 minimum for critical parts or critical characteristics, and for non-critical characteristics, 1.33. And now, can you see a shifted process? All of you? Is your process shifted or not? Shifted. When the process is shifting to the right side, what is the change you are observing? Can you see your blue bar reducing? The length of the blue bar is reduced, isn't it?
Yes.
The blue bar is the cushion available. Please note, all of you. The blue bar is the cushion. Cushion means the tolerance given by the customer. Earlier, the tolerance was this much, but now it is only this much. Why? Because your process is shifted. I don't know why. Whether it's a worn-out tool or if the setting is wrong, can be some reasons, right? You need to fix it. So now, in the shifted condition, you find out the ratio, USL minus X bar by 3 sigma. And here, X bar minus LSL by 3 sigma. You will get different value. All of you understand what I'm speaking now? You will get different value. Why you are getting different value? Because your process is shifted. So the numerator, one side is reducing. So out of the two value, which value you should pick up now? The lesser one or the bigger one? The lower one, smaller one. So 0.833 is your CpK. A CpK value of less than 1 theoretically confirms your process is not capable, which means there will be plenty of rejections, That percentage also we can find out. Okay. But no, please note, when our process, when CPK is 1, your process is just capable. CPK 1 means your process is just capable. Let me show you one process with just capable.
One question here.
Yeah, please.
So by seeing this graph, we can see my average is shifted towards the upper specification limit.
Correct. Your average is shifted to the upper specification limit. You're right.
Okay.
Very good. That's it. Okay. So now I think all of you are able to see my screen now, right? So, can you see my empty slide, all of you?
No, sir, we cannot.
You can't see? Okay, I have to share the screen, please. Yeah. So can you see my empty slide now? I have drawn a line. And now you see, this is my lower spec. And this is my upper spec. And my process is like this. Right? And now, this point. Okay. This point is my upper control limit. This point is my lower control limit. Hope all of you know the difference between upper control limit and upper specification limit, isn't it? Upper control limit are the extreme points from your process. Lower control limit, left extreme. But upper spec and lower spec are given by the customer. And now tell me, in this condition, what will be the CpCpk value?
Will be
Equal to 1?
Will be equal, and
CpK will also be equal to 1. This is the customer target. That is also the process average, right? This is the target. This is also the process average. Am I right? All of you are with me so far? I want all of you to tell me, confirm me whether this process is capable or not. This process is just capable. This process is just capable. And this process can be called as a 3 sigma process. What is the name of this process?
3 sigma.
Why do I call it 3 sigma process? Because center to the spec, the distance is 3 sigma. Am I right? Similarly, center to the left spec, that is also 3 sigma. So what is the name of this process? 3 sigma process. Clear, all of you? And we also know up to control limit, what percentage of the parts are expected to fall?
99.73.
99.73. When your process is just capable, please note, when your process is just capable or when your process is capable in this scenario, 99.73% of your parts are safe. What is the percentage of the parts inside the spec? 99.73. 99.73. So what percentage of your parts are under risk now? Risk means, risk means in this range, left side or right side. 0.27. All of you please note, this statement is true only when the process is not shifted. Am I right? But we very well know our process will shift. Somebody will, drift our process, pull our process to the right side, or somebody will pull our process to the left side. For example, in the training process also, do you think some participants are pulling our average? Yes or no? Some people are not able to attend the session. They're also not able to go through the recordings. Now, what are they doing? They are pulling our average downwards. Some people are putting more efforts, more participative, and they are trying to score high marks. They are pulling our average to the right. So the same thing will happen in any business process also. As long as that pulling is not there, shifting is not there, the process remains capable. But when the process is shifted, rejections will happen even in a 3 sigma process. Please note, a 3 sigma process, even though it gives a guarantee of 99.73% success rate, that 99.73 will get damaged when your process is shifted. Clear, all of you? 99.73 can easily drop to 90. And 5 to 10% rejection. Every time rejection is happening, every shift in your factory rejection is happening. You know why? Because of the shifting only. Right? And over and above the variation, there is a shifting. So now that you all understood what is a 3 sigma process, can you please, all of you, can you confirm? Do you now understand what is a 3 sigma process?
Yes, that's capable.
Can somebody define 3 sigma process by looking at my slide? What are the characteristics you notice when it is a 3 sigma process? Can you
Sir,
see the control limit?
CP
CP.
and
Sir,
CPK 1.
Sir, Gorakhpur
Very good.
അറിയാറുണ്ട്.
No, Jayakumar is talking somewhere. Okay, Sai Krishna clearly told, confirmed. Excellent answer. CP and CPK
CPK.
both are equal to 1. Am I correct?
Yes, sir.
Good observation. Good observation. Your process is a 3 sigma process. Very good. What are the other observation?
Sir, upper control limit, we are utilizing the total specification limits for control.
Very good. Upper control limit consumes, your process consumes all the tolerance. Control limit just overlaps with the specification limit. That is your point. Am I right?
Correct.
Yes.
Whenever the control limit overlap with the specification limit, then the process should be called as 3 sigma process. Whenever the yield is 99.73%, whenever the yield is 99.73%, the process should be called as
3 sigma.
Just
3 sigma process. These are the definition for 3 sigma process. In easy language, you can call the process as just capable. What is the capability? Just capable, because control limit has already touched the specification. If it goes one more step outside, the part will be rejected, isn't it?
Yes, sir.
This is known as just capable scenario. Do you think just capable scenario is good scenario? Can you go on vacation now?
No, sir.
No, sir. No.
You cannot. So very dangerous scenario. So you have to be there always. That is why 3 sigma capability is not enough. It is something similar to spending all your earnings in the same month. Like your salary is 2 lakhs, but your wife spends all the 2 lakhs in the same month. Are you capable now?
No, sir.
It looks capable, but actually, you can't handle any emergency. Even though you are earning a good money, but everything is spent in the same month. So that's what's
Yes.
happening here. Whatever tolerance given, you consumed all the tolerance. So this capability is not enough. That is why we think of higher capability. All of you now, do you understand why we need a capability higher than 3 sigma? We talk about 6 sigma capability. Why? 6 sigma capability means, imagine your earning is 2 lakhs a month and your wife is spending only 1 lakh a month. And now your capability is 6 sigma capability.
Okay.
You are now doubly capable. You are able to earn double the requirement. You are now doubly capable. A doubly capable process is known as a 6 sigma process. All of you understand?
Yes, sir.
Yes.
When
sir.
your process is just capable, CpCpk will be 1. When your process is doubly capable, CpCpk will be equal to 2.
1.67. 2.
Not 1.67, 2.
2. Okay, sir.
But 1.2 will drop to 1.67 even after your process undergoes some shift. You understand? Because we always know process will be shifted either to the right side or left side. After the shift, CpK of 2 will come down to 1.67. Right? That means a doubly capable process will remain capable even after a shift. Imagine you are earning 2 lakhs and regular spending monthly expense is how much? 1 lakh. Now an emergency happened. So you have to spend another 30,000 rupees. Will you be able to spend?
Yes.
Isn't
Yes,
it? You will be able to spend. So you are still, you are remaining capable. You're still remaining capable. So that is a point. And see here, now there is a summary. What is required? What is required is we don't want the process to get shifted. When the process never shifted, then only this condition will be fulfilled. You see here, Cp equal to Cpk. When this will happen? If the process is not shifting either to the right side or to the left side, only then Cp will be equal to Cpk. Do you want this scenario? Do you want your process to always stay on the target?
No,
Yes.
Yes.
sir. Always
Yes
on
is
the
the correct. Yes is the correct, expectation. I want my process to stay on the target. So expect the Cp to be equal to Cpk. Demand for a equal value of CpCpk. First point.
Okay.
If CpCpk are not equal, you can understand a pulling is happening. Who
Sir,
is
if-
pulling, which is pulling, why it is getting pulled, you need to investigate and bring back the average to the target. Yes, any question here?
Sir, if CpCpk is equal, then either it will be 3 sigma or 6 sigma. Only two conditions it will be equal. No, sir? Otherwise,
See, if they are equal, if they are equal, you can only say the process is not shifted. If they are equal, the process is not shifted. Process is centered properly.
okay.
But in order to talk about the capability, you should ask for the value of Cp and Cpk. I am not given the value. You see here.
Okay.
I
Yes,
am
sir.
only saying that Cp equal to Cpk.
Condition. Okay.
Cp equal to Cpk. But over and above, when I also say Cpk more than 1.67, now you understand if they are not only equal, they are more than 1.67. Now what do you understand? Your process is
More capable.
capable.
Yes.
So both the conditions have to be satisfied.
Okay.
Hereafter, if you are responsible for any process, this should be your expectation. CpK should be more than 1.66 or 67, and CpK must be equal to Cp.
Bottom one.
Clear all of you?
Cp is greater than 1.6.
Yeah. See, when CpK is greater than 1.66, automatically Cp will also be greater than 1.66. So hereafter, when you are talking to your team member, don't use Cp, right? Use CpK, right? And ultimately, try to make both of them same. Ultimately, try to make both of them same. If both of them are same means you have capable process with very good control. Cp is used to understand the control, statistical control. CpK is used to understand the capability. Okay. Whenever Cp and CpK are different, you can understand your process is shifted. Now this is required. Whenever they are not equal, the recommendation is you must move the mean to the target. All of you, do you understand the meaning of it?
Yes.
Mean means what? Mean means process average.
Average.
Whenever CpK is more than 1.66, your process is capable. I am also saying consistent. You know why I am saying consistent? Because when CpK is more than 1.66, Cp will automatically more than 1.66. So capability also comes, consistency also comes with the higher CpK. If CpK is not 1.66, capability is lost, but still your process can remain consistent. You understand? A scenario where Cp is acceptable, but CpK is not acceptable. Since Cp is acceptable, consistency is okay. But CpK is unacceptable, so capability is not okay. Okay, I think you all have understood the CpCpK very well now. And now there is a small example, and you can have any example here. Don't worry. There is a situation. Upper spec is 30, lower spec is 0. It can be, suppose if it is a bank, reimbursement process time, turnaround time, or if it is a manufacturing company, surface finish, right, roughness, whatever. Upper spec is 30, lower spec is 0. And process average is 22. Process standard deviation is 5.9. So I use the
5
formula
minutes.
to calculate CP. My CP is 0.8. Can somebody comment now? What's happening in your process?
Not
Process is
stable,
consistent.
Lunch time
not
1 hour.
consistent.
Not stable. I like the word not stable. Process is not in statistical control because CP is under trouble. When CP is under trouble, your CPK will definitely under trouble. Please note, all of you. Right? CPK can never be more than CP. And now I go with the CPK formula. And CPK, when you calculate, two value will come. Right side value is 0.4, left side value is 1.2. Which side is affected? Right side is affected. That means your process is shifted to the right side.
For specification.
Rejections will happen at the upper spec. So out of the two, the lower value you should take 0.4. CPK is also unacceptable. CP also unacceptable. So you have to take two action. One is move the mean. Why you should move the mean? CP and CPK are different. Am I right? 0.4, 0.8, they are different. So move the mean towards the target and also reduce variation. Variation is also playing. We don't know which variation, whether it is shift to shift variation or operator to operator variation. I don't know, or raw material variation. You need to find out. But definitely the variation is big. So two recommendations are given statistically. But practically, in real time, what needs to be done? That has to be brainstormed, investigated, and then action must be taken. All of you understand here the recommendation? Any doubt? All clear, right? Okay.
Yes.
Now another scenario. Upper spec is 110, lower spec is 90, process average is 107, process standard deviation is 1.5. So CP equal to 2.22. Can somebody tell me what will be your conclusion now when you see CP equal to 2.22? More than...
So it is towards upper
Process is stable.
specification limit.
Process is consistent.
Stable.
Consistent.
Very good. Process is stable, consistent, statistical control. Variation is
Under statistical.
absolutely minimal. But you need to conclude about the capability after looking at CPK. When I calculate CPK, left side absolutely no trouble, but right side there is a big trouble, 0.66. So I don't have to do anything with the variation, but definitely my process should be retargeted. I must shift the process towards the left. I mean, move the process mean close to target. When I
Towards
do
the
that,
target.
my CPK will improve. Now another scenario. Upper spec equal to 0.5045, lower spec equal to 0.5025, and average is 0.5031, standard deviation is 0.0003, CP equal to 1.11. For a critical process, 1.11 is unacceptable. And so the recommendation is reduce variation. Clear?
Yes.
And I calculate CPK. Two values, 1.55, 0.66. They are different.
So from left to
So
target
minimum
we
I
need
should
to
take.
track.
0.66 I should take. And this time the process is shifted to the left side or right side?
Left side.
Left side. So move the
To
process
right
average
we need.
close to the target. And this is the recommendation, statistical recommendation. I see as a consultant, we can simply say, hey, move the average. But how will they move the average? For example, if all your performance, exam performance, if the average, class average, our target is how much? We said 90. But all your average is only 45. Now, how can I move the average upwards? Maybe increase the number of hours of the class, isn't it?
Yes, sir.
Increase some model
Efforts.
mock exams. Mock exam, extra classes, extra exams. With all these efforts, we can push the average. That is called move the mean. Similarly, what needs to be done, you need to find out. Now tell me, all of you, what should I do? CP equal to 0.94, CPK equal to 0.33, and process is not capable. What action is needed now?
Reduce the variation and
Very good.
move to the mean.
Very good. Fantastic. So you all have understood. Capability can be measured in terms of yield. And within yield, you have three types. First pass yield, rolled throughput yield. And now for continuous data, we can use CP and CpK. And you all know first pass yield means we want to produce the products without doing any rework. That is the objective for first pass yield. And DPMO stands for defects per million opportunity. But now coming to CP and CpK, CP only compares the process width of the process with the width of the specification. But CpK, in addition to comparing the process width and specification width, it will also check whether the process is centered on the target or not. That's why it is advantageous. For critical process, we want both CP and CpK to be more than 1.67. And in an ultimate scenario, CP will be equal to CpK. In an ultimate scenario, CP will be equal to CpK. Similarly, for non-critical process, both of them should be more than 1.33. So this completes our discussion on CP and CpK. I hope all of you have now understood, how to use CP and CpK. Am I correct?
Yes.
Yes, sir. Yes, sir. Yes, sir.
Excellent. If there are any questions, you can ask.
Sir, actually, I had only one doubt.
Yeah, please.
CpK is 1.33 means how much sigma, sir? For example, 6 sigma means 1.67. 3 sigma means 1. In 1.33 means...
No, you are confusing. 1.67, 1.33 are requirement for CP and CpK. All right? Requirement for CP and CpK. And there is no rule for sigma. Sigma should be this much, that much. No. See, the value of sigma can vary from company to company. You understand? It depends on your data. Based on the data only we calculate. So there is no specific recommendation for how much will be the sigma. No.
Okay.
But CP and CpK should be more than 1.67. Sigma can be any value. Only your process data can tell that.
Okay.
All right?
Okay.
Any other question anybody would like to ask?